Hello everyone, welcome back to another video. This is Pranav, and in this video we'll be talking about representing knowledge in an uncertain domain. So coming to the introduction part, uncertain domains referred to as areas in which there is incomplete or ambiguous information, or information that is not classified or that cannot be seen. In which advanced AI systems need to be able to handle uncertainty in order to make accurate decisions. So, as we know, AI systems are used for prediction and analysis. So, in this, AI systems need to be able to perform functions on data that are not ambiguous or that are in uncertain domains. So, representing the knowledge in uncertain domains is essential for AI systems to effectively operate in the real world scenarios. In which we can see the core areas of artificial intelligence, that is sensory AI, IoT, and then second one being physical AI and industrial automation, cognitive AI, general AI, precision AI, and explainable AI. So these are the different domains in which AI systems can be used, and in real world scenarios, in each domain there are certain uncertain domain. I mean, there are certain uncertain sets which are not ambiguous. So the challenges in representing the knowledge in uncertain domains are uncertainty arises due to limited data or conflicting information or changing circumstances. That is, it may change over an instant, so it may keep changing dynamically. And representing uncertainty requires capturing probabilistic relationship between the variables, that is, in the previous state to the next state to the next state. So that is the transition states, and balancing the trade-off between accuracy and efficiency is a major challenge in uncertain domains, because for the AI systems to be accurate, the efficiency also must be pretty good. So balancing it off is a pretty neat task. And representing uncertain knowledge, some of the key points are symbolic and numeric uncertainty, the closed world assumption in which everything is defined, and predicate completion, that is using prediction using predicates, and taxonomic hierarchies to be able to predict using hierarchies, and abduction, truth maintenance, base rule, certainty factors, and fuzzy sets. So these are some few key points. Probabilistic models for representing uncertain knowledge. That is, coming to the first one, that's Bayesian networks. So, Bayesian networks are graphical models that use directed acyclic graphs to represent probabilistic relationships amongst a set of random variables. So, they are widely used for uncertain knowledge representation in various fields such as healthcare, finance, and natural language processing. BNs allow modeling dependencies. Sorry for that. BNs allow modeling dependencies between variables and make probabilistic inferences based on observed evidences. So they have certain variable dependencies that make it easier for the probabilistic inferences that are in Bayesian networks, and which can be observed as an evidence. So the second one being Markov decision. So Markov networks are undirected graph models that represent probabilistic relationship amongst variables, they are used in situations where BNs might not be sufficient. So this is like an advanced system. So especially for model complex interactions between variables with symmetric dependencies. And the third one being hidden Markov models, wherein HMMs are statistical models used to model sequences of observable variables whose underlying states are hidden. That is, you have certain set of states which are visible to the human eye, or which are predictable, and there are few states which are not. So these are statistical models in which they are trained to sequences of observable variables whose underlying states are hidden, and they are widely applied in speech recognition, bioinformatics, and natural language processing for modeling sequential data with uncertain state transitions. So HMMs are an application in many AI fields and deployments such as text to speech or text recognition, etc. Fuzzy logic for handling uncertainty. So fuzzy logic allows for the representation of imprecise or vague information. Fuzzy sets and membership functions are used to assign degrees of membership to elements, and fuzzy rules and fuzzy inference engines enable reasoning and decision making in uncertain domains. So Fuzzy logic helps in handling the imprecise data, that is traditional logic relies on crisp binary values, that is true or false, whereas fuzzy logic allows for degrees of truth, and this is particularly useful for dealing data that is not clear cut and contains ambiguity or imprecision. So the second one being linguistic variables and fuzzy sets, and that is fuzzy logic uses linguistic variables and fuzzy sets to represent um, vague concepts linguistically. That is, for an instance, let us say hot, cold, fast, or slow can be represented in fuzzy logic to capture their inherent uncertainty and subjectivity. The third one being membership functions, that is, fuzzy logic employs membership functions to address degrees of membership to elements in a set. That is, inside a set, we have declared fuzzy variables or linguistic variables, and these are also assigned, membership functions, that is, to assign degrees of membership instead of strict categorization. So this is a different approach, and membership functions enable a gradual transition between being a member or not, and that is allowing for more nuanced representation of uncertainty. So AI approaches for uncertain knowledge representation, that is probabilistic reasoning. As we just saw, we went through a few methods, that is probabilistic graphical methods such as Bayesian networks, Markov networks, and HMMs, that is hidden Markov models, are extensively used to represent uncertain knowledge. They model relationships between variables probabilistically and allow for reasoning under uncertainty. The second one being fuzzy logic, as we just saw. Fuzzy logic is employed to represent and reason with uncertainty or imprecise information. It enables representation of uncertainty through linguistic variables and fuzzy sets, allowing for approximate reasoning. So, third one being ontologies with uncertainty. That is, ontologies augmented with probabilistic extensions or fuzzy logic can handle uncertain knowledge representation, and these allow for the explicit representation of uncertainty in relationship between entities in a domain, that is through across domains. And Bayesian networks in AI planning. So Bayesian networks is also used or are also integrated into AI planning systems to model and reason about uncertain states and actions and outcomes. So this incorporation of uncertainty helps in decision making under partial observability. So evaluation and validation of uncertain knowledge can be done in this particular method. That is, metrics such as accuracy, precision, recall, and F1 score can be used to evaluate the performance of uncertain knowledge representations. That is, to train the models and to be able to test the degree of uncertainty. And this can be done using cross validation techniques, and cross validation techniques can access the generalizability of the models, and in real world testing and user feedback are crucial for validating the effectiveness of uncertain knowledge representations. On the right hand side, you can just see confusion matrix, wherein the number of states can be predicted for true positive, true negative, false positive, and false negative for any particular scenario. And the confusion matrix is one of the methods inside evaluation. So, applications of uncertain knowledge, that is, autonomous driving systems rely on uncertain knowledge representations to navigate complex environments. So, you might be having an AI driving system to drive a car, so but there might be uncertain circumstances such as a person just appearing in front or any kind of disruptions in the road. So, this is uncertainty. So, this can be trained over a period of time for the AI systems to be able to see the hidden states. So it cannot always be based on the visible states, it is also based on the hidden states. So this is how Bayesian networks or inferences are used. And in healthcare systems as well, we use uncertain knowledge representations to assist in diagnosis and treatment decisions. This may also be an approach in healthcare systems to improve accuracy. And financial prediction models leverage uncertain knowledge representations to make informed investment choices. Or also in our day-to-day lives, we can see traders using AI systems lately to predict and use analysis on the growth or decline of markets, and to have financial prediction models. So, coming to the conclusion part, we have representing knowledge in an uncertain domain is crucial for advanced AI systems to make accurate decisions or to increase the accuracy. So, probabilistic models, fuzzy logic, machine learning, and hybrid approaches are used to handle uncertainty effectively, and ongoing research and advancements will continue to improve the representation of uncertain knowledge in AI systems. So, thank you guys for watching the video. Hope you guys understood the topic.